Hello everyone. Today we'll start with a new chapter which is on correlation and regression analysis. But for now, for today's lecture, we'll go through what is correlation. Okay. So since you can see here, correlation is a word made up of two letters. I mean two words in itself. That is co and relation. Co meaning together and relation means a connection or an association. Okay, so correlation is nothing but it is a statistical tool which will help you to measure and analyze the degree of relationship which is there between any two variables. So if you are given any two variables, you will be able to make out whether they are related or they are not related by coefficient of correlation, that is correlation. Okay, so I can say that correlation deals with association between two variables. Now the question is, how will you measure? अगर आपको दो वेरिएबल्स दे दिए गए हैं तो आपको कैसे पता चलेगा कि whether they are related or they are not related? If they are related, then how they are related? Okay, so we are talking of measurement. How will you measure the coefficient? How will you measure the correlation? Correlation can be measured by coefficient of correlation. Coefficient of correlation is something which will let you know the degree of association between two variables. This coefficient of correlation is denoted by the letter R. Here the letter R denotes coefficient of correlation. Now coefficient of correlation also has two other names: Karl Pearson's coefficient of correlation, or it is also known as product moment correlation. Okay, so coefficient of correlation is also known as Karl Pearson's coefficient of correlation and product moment correlation. Now this value R, this R takes a value from -1 to 0 to +1. That is, your value of R can be negative or positive, or it can be 0 also. Now let us see what happens when R is positive. Okay, positive correlation, or the value of R being positive, means that with an increase in one variable, your another variable is also increasing. So both your variables are moving in the same direction. We'll take one example: study time and grades. Okay, so it is very much obvious कि जितना टाइम मैं स्टडीज़ में ज़्यादा लगाऊंगी मेरे ग्रेड्स उतने ज़्यादा अच्छे आएंगे. Done. If I spend less time in studying, my grades will be poorer. If I study for more time, then my grades will also be good enough. Okay, so with an increase in x, that is my study time, my y, that is my grades, will also increase. Both will move in the same direction. With an increase in study time, my grades will increase. With a decrease in study time, my grade will decrease. Hence, I can say that study time and grade are positively correlated. Let us take another example. Let us say that the temperature of the day and sales of ice cream. Okay, it is very much obvious that in summers, when the temperature is more, the sales of ice cream will shoot up. Okay, so with an increase in temperature, the sales of ice cream will also increase. And in winters, when the temperature is low, hence when the temperature is low, the sales of ice cream will also come down. With increase in temperature, sales of ice cream increases. With decrease in temperature, sales of ice cream decreases. Hence, I can say that both my variables, temperature and sales of ice cream, are positively correlated. Why? Because both of them are moving in the same direction. Okay. Last example we'll take of positively correlated as demand and price. Okay. You know that when the demand of a certain commodity increases, its price also tend to increase. Okay, we are talking of normal goods. We are talking about normal goods only. When the demand of a certain commodity or good increases, the price of that commodity will also increase. Vice versa, when the demand will decrease, the price will also decrease. So I can say that demand and price are positively correlated. My two variables, demand and price, are positively correlated. I'll state a simple, very simple example on negative correlation, which is price and quantity. A basic law of demand states that with an increase in price, quantity demanded decreases. I repeat, with an increase in price of any commodity, the quantity demanded decreases. Again, I'm talking of normal goods only. Please refer here uh, to normal goods only, okay, not any other inferior goods or anything like that. We are talking about normal goods. With an increase in price of any normal good, its quantity demanded decreases. If you can see here, both my arrows are flowing in opposite direction. ठीक है, यहाँ पे एक इंक्रीज होने पे दूसरा इंक्रीज वेरिएबल इंक्रीज होता था, लेकिन यहाँ पे एक वेरिएबल के इंक्रीज होने से दूसरा वेरिएबल डिक्रीज हो रहा है. Hence I can say that price and quantity, my both the variables are negatively correlated. Okay. Similarly, you can say that when the price of a certain commodity decreases, जब किसी commodity की price कम हो जाती है तो obviously उसका क्वांटिटी डिमांडेड जो है, जो डिमांड जो होता है मार्केट में, वो इंक्रीज हो जाएगा. बोथ माई एरोज आर फ्लोइंग इन अपोजिट डायरेक्शन, सो आई कैन से दैट प्राइस एंड क्वांटिटी, माई बोथ वेरिएबल्स आर नेगेटिवली कोरिलेटेड. ओके, ये तो हो गया व्हाट इज पॉजिटिव कोरिलेशन एंड नेगेटिव कोरिलेशन. नाउ व्हाट इफ योर आंसर ऑफ आर कम्स टू बी ज़ीरो. अगर आपके आर का आंसर ज़ीरो आ रहा है तो व्हाट कैन यू से? When your answer of R comes to 0, you can say that there is no relationship or there is no correlation between your two given variables. Okay, आपके दोनों वेरिएबल का एक दूसरे के साथ कोई भी रिलेशनशिप नहीं है. That is the meaning of R being 0. Okay, now ये तो हो गया कि R होता क्या है. R is something, R is known as coefficient of correlation. वो आपको बताएगा कि आपके दो वेरिएबल्स के बीच में डिग्री ऑफ एसोसिएशन कितना एसोसिएटेड, अगर है तो कितना है, अगर नहीं है तो क्या है. ओके, वो बताएगा R. नाउ यू माइट बी हैविंग अ क्वेश्चन कि ये R को मेजर कैसे करते हैं. हाउ डू यू मेजर R? There are various methods of measuring R. I'll tell you first, the simplest method is by scatter plot diagrams. Okay, scatter plot diagram मतलब क्या? Scatter plot diagrams are simply Cartesian graphs. Okay, when you plot your x variable का value versus your y variable का value, you see these dots? These dots are your values of x versus y. Okay, when you plot these diagrams, you plot these observations, you will get a certain diagram. जैसे ये हो गया. Okay, I am taking my x value, y value, plotting it in a Cartesian form. अगर मेरा पैटर्न ऐसे आ रहा है, ठीक है, I see my dots flowing from origin towards up, ऊपर की तरफ जा रहा है. ठीक है, you can see this line, ऊपर की तरफ जा रहा है, तो आई कैन से दैट देयर इज अ पॉजिटिव कोरिलेशन. मतलब विद एन इंक्रीज इन वैल्यू ऑफ एक्स मेरा वाई भी इंक्रीज हो रहा है. जैसे ये देखो, एक्स के इंक्रीज होने से वाई इंक्रीज हो रहा है, एक्स इंक्रीज हो रहा है, वाई भी इंक्रीज हो रहा है. ओके, सो व्हेन योर डॉट्स आर फ्लोइंग फ्रॉम ओरिजिन टुवर्ड्स अप, you can say that there is a positive correlation, completely positive correlation between your two variables x and y. Okay, opposite is also true. अगर आपके डॉट्स स्कैटर प्लॉट के सारे डॉट्स ऊपर से नीचे की तरफ आ रहे हैं, आई रिपीट, व्हेन ऑल द डॉट्स आर फ्लोइंग फ्रॉम अप टूवर्ड्स डाउन, ऐसे यू सी दिस डॉट्स, तो दिस लाइन shows you negative correlation, means your variables x and y are negatively correlated with each other. मतलब एक के increase होने से दूसरा decrease हो रहा है. You see this? X here has the highest value, but y here has the lowest value. Similarly, x के decrease होने से आप देखोगे कि y हो रहा है increase. Okay, so this means that x and y are negatively correlated. Last, when you have your dots not following any pattern, कोई pattern ही नहीं बन रहा है यहाँ पे. If you see this space, there is no pattern being formed here, so you can say that your variable x and y are not correlated, completely uncorrelated. मतलब x और y के बीच में कोई भी relationship नहीं है. That is when your r is 0, तब की बात है ये. Okay, simple. ओरिजिन से ऊपर की तरफ डॉट्स जा रहे हैं, तो यू हैव योर वेरिएबल्स एक्स एंड वाई टू बी पॉजिटिवली कोरिलेटेड. व्हेन योर डॉट्स आर कमिंग फ्रॉम अप टूवर्ड्स डाउन, ठीक है, तो यू कैन से दैट योर एक्स एंड वाई वेरिएबल are negatively correlated, and when you do not observe any pattern in the dots, you can say that they are completely uncorrelated या फिर not correlated. Okay, this is the first method, the simplest one, जहाँ पे you can make out the relationship between two variables just by seeing the graphs. Second is the method, second is you find out the value of r, you calculate the value of r, the calculation part of r which is coefficient of correlation को calculate करने की बात यहाँ पे आ रही है. Okay, तो the first basic thing is remembering the formula of r or coefficient of correlation is given by COVXY. COVXY मतलब क्या? COVXY means covariance. I hope you remember what is variance, right? We did it in the last chapter. Variance was for one variable. When we are referring to two variables, we study something known as covariance. Okay, so coefficient of correlation r is given by covariance COVXY, मतलब covariance of x and y divided by sigma x into sigma y. I hope you know sigma x stands for standard deviation of x and sigma y stands for standard deviation of y. Okay, this is the basic formula of calculation of r which is coefficient of correlation. ठीक है, now what is COVXY? COVXY का formula क्या है? COVXY या फिर covariance of x and y is given by this formula, sigma of x into y upon n minus sigma of x upon n into sigma of y upon n. The very much important part about this particular module is that you need to remember all the formulas very properly. Okay, once you remember the formulas, there is no rocket science left to do because all the work will be done by your calculator. I hope you remember the formula of standard deviation. Standard deviation of x is given by under root sigma x square by n minus sigma x by n the whole square. Similarly, this is the formula for standard deviation of y. What you need to do is when you get the sum, you need to remember this. From this, you should know the formula for covariance. Calculate x into y, sigma x, sigma y, sigma x square, sigma y square. So we need to calculate sigma xy, sigma x, sigma y, sigma x square, sigma y square. 1, 2, 3, 4 and 5 things. You need to calculate 5 things, put in the formulas and tada, you are done. You are done with the value of rxy. Okay. Now the question arises that how do you do the sums? Okay, so you will be having a variety of sums wherein you will get the values of x and y to be smaller. Like in this sum, you see the value of one variable is small, takes the value of 1, 5, 8, 6, 7, 4, small values. Similarly, the value of y is also 2, 1, 5, 7, 6, 3, smaller values. Okay, when you have smaller values, how will you calculate? You just need to calculate by using the formula I just showed you. This, simply multiply your two variables. Okay, have a summation of that, get the square of x, get the square of y, get a summation of that. Okay, that is the simplest form of calculation of r. Now we move forward to what if your values are a bit larger. ठीक है, जैसे यहाँ पे values थी 1, 5, 8, 6, 7 smaller values, but what if your values are like this 155, 157, 153, 151. आई होप यू गेट इट कि इनका स्क्वायर करना, इनको आपस में मल्टीप्लाई करना बहुत ही मतलब बड़ा नंबर आ जाएगा. इफ़ यू डू 153 स्क्वायर, ओके, द आंसर विल बी 23409, अ बिग नंबर, वेरी वेरी बिग नंबर. ठीक है, इफ़ यू मल्टीप्लाई 155 and 118, you arrive to 18290, a very big number. You have to multiply big numbers, have a summation of that, have square root of that. Okay, it will be a tedious job. What will happen when you have these values? You can approach this formula here, this formula. When your values are a bit tacky, by tacky I mean they are a bit larger, okay, not in single digits. What you have to do is you have to reduce them to smaller values. ठीक है, how will you reduce it? By subtracting from a constant. You can take up the constant from the observations itself. Okay, in this case your COV xy will now become COV of capital X and capital Y. What are capital X and Y? Capital X is nothing but the reduced value. Here C and C dash are constants. कौन से कॉन्स्टेंट्स हैं जो हम ऑब्जर्वेशंस में लेंगे और उसमें से ही माइनस कर देंगे, वो वाले हैं. ठीक है, यू विल गेट अ बेटर आइडिया व्हेन वी विल सॉल्व द सम, ओके, इन दिस पर्टिकुलर सेशन इटसेल्फ. सिमिलरली आपका स्टैंडर्ड डिविएशन हो जाएगा. स्टैंडर्ड डिविएशन ऑफ स्मॉल एक्स विल बिकम इक्वल टू स्टैंडर्ड डिविएशन ऑफ कैपिटल एक्स, which is equals to under root capital X square by n minus capital X by n the whole square. What is capital X? Please do not forget, it is nothing but the reduced value of your original observations. Okay, so in this case your rxy, that is coefficient of correlation of small xy, will be equal to r of capital XY, which is covariance of capital XY जो आप यहाँ से कैलकुलेट कर रहे हो. ठीक है, अपॉन स्टैंडर्ड डिविएशन ऑफ कैपिटल एक्स जो ये है, अपॉन स्टैंडर्ड डिविएशन ऑफ कैपिटल वाई जो ये है. ठीक है, इजी. नाउ द लास्ट मेथड, और आई शुड से द लास्ट सेट ऑफ calculation is when your values are extremely large, or I'd say they are a bit, they fall in a way that it will make your calculations very much complicated. Imagine 360, 420, 500, 550, big numbers, really big numbers, and you have 100, 104, 115, 160, really big numbers. Like imagine 360 into 100, that makes 36 and 3 times 0, all a big number. Imagine having such 5-digit numbers, adding them and then finding the square root and then subtracting them. Tedious job. I mean, it is very much possible that you may make mistakes even using the calculator. So हम क्या करेंगे? We will go towards more reduced method. यहाँ पे your COV of original observation xy will be given by covariance of u into v into d into d dash. Please do not panic, I'll tell you what they mean. COV, covariance of u and v. What is u and v? U is nothing but your original observation x reduced by some constant, जैसे हमने यहाँ पे किया था. ठीक है, reduced by some constant upon another constant d. I hope you remember we followed this method while doing sums in the previous chapter. ठीक है, स्टैंडर्ड डिविएशन के सम हमने किए थे, उसमें भी यही मेथड की थी. द सेम मेथड यू हैव टू फॉलो. सिमिलरली y को आप रिड्यूस कर दीजिए c डैश से एंड डिवाइडेड बाय सम कांस्टेंट d डैश. ओके, ऑल्सो Your standard deviation will be given by sigma x will now be represented by sigma u, which is equals to sigma u square by n minus sigma u by n the whole square. Similar formula we have for sigma y, which will now be represented by sigma v, that is standard deviation of y equals standard deviation of v, which is given by summation of v square by n minus summation v by n the whole square. Please do not panic. This is no rocket science. You have to just choose the formulas according to the values of x and y that you have. The formula, however, remains the same. The main formula, however, remains the same, which is r of xy is covariance of xy upon sigma x into sigma y. This is all that you need to remember. Depending on the values of variables that you get, you choose from 1 to 3. Okay? We'll do sums on all the 3 methods so that you don't have to panic. Okay, but just look at this. In the last method, r of xy will be given by r of uv. Here, please remember here, if you are following this method, your COV of uv is not just plainly COV of uv, it is multiplied by d and d dash. What are d and d dash? The denominators that you took here. You need to multiply with your covariance here and then divide them by the respective standard deviations. Okay, now we shall see sum on this. Okay, got this. Sum number 1. Compute the value of R for the following ranks of a group of students in 2 examinations. Okay, so you are given a BCom ka examination, bachelor's ka examination, and you have been given MCom examination, मतलब master's ka examination. Usme these are the rank of a group of students. I mean, somebody stood first in BCom, then stood second in MCom, the same person stood second in MCom, and so on is the data that is given to you. You are required to find out the value of R. Compute the value of R. R means coefficient of correlation. Okay. Now, first of all, first thing that you need to do after seeing the sum is look at the values of x and y that are given. They are small, single digit information you can easily deal with. No need to reduce them. Okay, ऐसे इसका square करके आप कर सकते हो, simplest form. So what is the formula of R? I'll recall the formula. R of xy is given by covariance of x and y upon sigma x into sigma y. Easy? Okay. Now, what is COVXY given by? COVXY is given by summation of xy upon n minus summation of xyn into summation of y by n. ठीक है. What is sigma of xy? That standard deviation of x given by. Standard deviation of x is given by square root of summation of x square by n minus x by n the whole square. Similarly, this is given by square root of x y square by n minus summation of y by n the whole square. Okay, इतना लिखने से what do we get to know कि हमें चाहिए क्या, what do we need to compute. इतना लिखने से हमें ये पता चलता है कि हमको ढूंढनी कौन सी चीज़ है. पहले तो मुझे x और y का समय मतलब मल्टीप्लिकेशन चाहिए, ठीक है, उसका समेशन चाहिए. फिर मुझे इंडिविजुअल x का समेशन चाहिए, इंडिविजुअल y का समेशन चाहिए, x स्क्वायर चाहिए, y स्क्वायर चाहिए. विल डू दैट. ओके, ये जो BCom का एग्ज़ाम है आई विल कॉल इट एज x. MCom का जो एग्ज़ाम है आई विल कॉल इट एज y. आई विल राइट दीज वैल्यूज विच आर गिवन टू मी इन द क्वेश्चन. 1 5 8 6 7 4 2 3 9 10. Here I have 2 1 5 7 6 3 4 8 10 and 9. Okay, looking at the formulas, I know that I need x into y. ठीक है, I need x square, I need y square, and the summation of everything which is there here. Okay, simply now we'll multiply these two. 1 into 2, 2, 5, 40, 42, 42, 12, 8, 94, 90, 90. Okay, if we add all these, we get the summation of x and y to be 3, 5, 5. Okay, yeah, we will sum these up also. So if you sum all these up, that is 1 plus 5 plus 8 plus 6 and so on, you will get summation of x to be 55 and summation of y also to be 55. Now I need x square and y square values quickly. 1, 25, 64, 36, 49, 16, 4, 9, 81 and 100. Similarly, y का स्क्वायर चाहिए मुझे, तो 2 2s are 4, 1, 5 5s are 25, 49, 36, 9, 16, 64, 100 and 90. Summing these up, what will be the answer? 385, 385 each. You'll get the same summation because the data is such. Not always possible. Okay, it is not always true कि आपका x square और y square का summation का आंसर सेम आए, क्योंकि यहाँ पे डेटा ऐसा दिया गया है इसलिए सेम आ रहा है. Okay, since these are ranked, it will fall from 1 to 9 only. Okay, now what do we have to do? Just put these things into the formula. First I'll find COV of xy. COV of xy is given by summation xy by n minus summation x by n, summation y by n. It is very important to keep writing the formula so that जल्दी याद हो जाएगा आपको. ठीक है, summation of xy is 355. 355 divided by n. N here is the number of observations, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously 10. Okay, minus sigma x. Sigma x मतलब summation x का value, which is 55 by 10. Summation y is also 55 by 10. Okay, you can easily calculate this thing on your calculator. You will get the final answer of covariance of xy, that is COVXY, to be 5.25. Okay, next I need standard deviation of x. Standard deviation of x is under root summation x square by n minus summation x by n whole square. Okay, I'll just put in the values. X square by n, that is 385 by 10 minus 55 by 10 whole square. You can easily calculate this on your calculator. You can use a scientific calculator or a simple calculator. You'll get the same answer. The answer of standard deviation, mind you, after getting a square root, will be 2.872. It is better if you take at least 3 places after the decimal. Okay, please take 3 places after the decimal point. Similarly, I will calculate standard deviation of y. Standard deviation of y is y square by n minus y by n the whole square. Putting in the values, I will have the same thing, obviously. Minus 55 by 10 the whole square, which is equals to, again, 2.872. Okay, I just have to put all these things into my formula of RxY being the coefficient of correlation, equal to COV of xy upon sigma x into sigma y. COV of xy. What did we get the value of COV of xy to be? 5.25. Upon these standard deviations that we calculated, 2.872 into 2.872. Do this. 2.872, square it, and then you have to, you got the answer to be 0.636, which is obviously positive. Your R of xy is 0.636. Now, positive here means, there will be times when you get the value of R to be negative also. Positive here shows that your x and y move in same direction. That is, with an increase of x, you get an increase of y also. Okay, and this is the degree of correlation. कितने related है x variable और y variable एक दूसरे से कितने related है? The value that you get closer to 1 will be a perfect correlation. जैसे values हो गई 0.95, ठीक है, 0.98, 0.9. Okay, values closer to 1 will show a perfect correlation. Okay, yeah, we are done with the first type of sum. A sum wherein you have your values of x and y, मतलब x और y variable की जो values होती हैं वो छोटी हैं. The variables are in 1 digit only. It is the simplest thing to do. You just have to calculate x into y, x square, y square, sum all them, and just put in the formulas. But you need to remember the formulas. That is something that you need to remember. Okay, and next set of sum wherein you have a bit difficult values, as in you can see the value here, it is 155. I'll tell you the question. Question is calculate the coefficient of correlation between x and y. Here my x takes the value of 155, 157, 153, 151, 159, 162, 158, and so on. Similarly, these are the values of y. I have to find the coefficient of correlation r for these. Okay. Now, as I was telling, these are a bit bigger values, so I will follow the method number 2. Method number 2, wherein I will be reducing these observations by a certain constancy. Let us see how. R of xy will be given by R of capital XY, which is covariance of capital XY upon standard deviation of capital X, standard deviation of capital Y. What is this capital X? How is it different from small x? Your capital X will be x minus c, capital Y will be small y minus c dash. Now c and c dash will be the values which you will take from here itself. Let us see how. I'll write down what is given to me. X 155, 157, 153, 151, 159, 162, 158. Small y 118, 129, 125, 124, 129, 133, and 127. These are the values which are given to me in the question itself. Now I will reduce them. I will find capital X, which will be x minus one value from this. I will take my value of c to be this. Okay, and I'll take my value of c dash to be this. So my capital X will be x minus 151. So I'll have to reduce all my observations by 151. So I need to do 155. 155 minus 151, which gives me a 4. 157 minus 151, which gives me a 6. Similarly, here I have 2. 151 minus 151 is 0, obviously. 8, 11, and 7. Similarly, I have my capital Y to be observations minus 1 to 4. That is, I'll reduce all my Y observations. ये सारे जो observations हैं उसको reduce कर दूंगी 124 से. मतलब 118 minus 124 करूँगी, which is minus 6. 129 minus 124 करूँगी, which is 5. ठीक है, 125 minus 124, which is 1. 124 minus 124 is 0. 5, 9, and this is 3. Now if you see, you had values like these in 3 digits which you reduced to be in 1 digit form. It is easier to square these, multiply these, and deal with a single value digits than to deal with a 3-4 digit number. Okay, yeah. Now I have to do the same thing. I have to find the value of x square, y square, xy as we did in the previous sum. Okay, वही चीज़ करनी है फिर से. Okay, x square, 4 square, 16, 36, 4, 0, 64, 11 square, 121, 7 square, 49. Okay, अब y की वैल्यूज़ का स्क्वायर मुझे करना है. -6 का स्क्वायर हो जाएगा पॉजिटिव 36. 5 5s are 25, 1 0, 25, 9 9s are 81, 3 3s are 9. Now I need to multiply these two, मतलब x and y, इन दोनों का मल्टीप्लिकेशन मुझे चाहिए. 6 4s are 24 but with a negative sign. Why? Because मेरा 6 negative है, इसलिए 6 4s are -24. Similarly, 6 5s are 30, 2 1s are 2, 0, 8 5s are 40, 11 9s are 99, 7 3s are 21. Okay, now I need summation of all of these for my calculation of covariance and standard deviation. Okay, इसका summation होगा 38, इसका होगा 70. Get a summation of x square to be 290, this to be 177, and this to be 168. Okay, what did I do? I just added up these values, just adding up these values, so you'll arrive at these numbers. Okay, now quickly, what do we need to do? We need to find the covariance of x and y. Covariance of x and y is given by summation of x into y by n minus summation of x by n into summation of y by n. Simply, what did we do? We just reduced. So we don't need to multiply. We do not need to multiply anything in covariance. Okay? Yeah. Summation of x into y. X into y, 168. Total number of observations, 1, 2, 3, 4, 5, 6, 7. So your n here is 7. Okay, yeah, 38 upon 7, summation of y is 17. 17 upon 7. When you calculate this using a calculator, you will arrive at a value 10.816. As I said previously, please take 3 digits after the decimal place. Okay, yeah. Now I need to find out my sigma of capital X, that is standard deviation of x, which is given by summation of capital X square by n minus summation of capital X by n the whole square. Please observe here, after reducing the values, I no longer need my original values. ठीक है, एक बार मैंने reduce करके ये numbers ला दिए, फिर इसके बाद इसका use कहीं नहीं होगा, इसकी मुझे अब ज़रूरत नहीं है. Okay, just putting in the values. Sigma x square का sigma, which is 290 upon 7 minus sigma x 38 by 7 the whole square. After doing this calculation, we will get the value to be 3.458. Similarly, if you calculate sigma y, that is standard deviation of y, it is given by this formula. ठीक है. Now it is simple. You just need to put in the values. Summation of y square का summation is 17 by 7 minus y by n, summation of y, oh I'm sorry, 177 by 7 and 17 by 7 the whole square. Okay, after doing this you will get the value of sigma y to be 4.403. okay, yeah. Now what do we need to do? We just need to put these three values in this formula number 1. Okay, we do that. COV of small xy, which was the original, R of small xy, which was your original observations, is given by R of capital XY. What is capital XY? The reduced numbers, the reduced values that we got is given by covariance of capital XY upon summation of x into summation of y. These we already found out. Covariance of x into y is given by this 10.816 upon 3.458 into 4.403. If you calculate this on your calculator, 3.458 into you will get the answer to be 0.710. That is 0.71. So your value of coefficient of correlation between these two values is 0.71. Just look how beautifully we just reduced the values from a 3-digit number to 1 digit, and then this was easy to calculate. Now imagine if you would have taken these original values, squared them, multiplied them, you would have got a 5-6 digit number, okay, which is a bit difficult to deal with. The last method is when you have your observations or the values of your variables to be too large. By too large, I mean this example. Calculate the coefficient of correlation between income and expenditure for a certain item for the following data. So you have been given a data wherein income दी गई है आपको, ठीक है, और उसके सामने एक्सपेंडिचर दिया गया है. आपको इन दो वेरिएबल्स के बीच में you have to calculate the coefficient of correlation. Now just I want you people to just observe the values, how large they are. Here this is the deciding point where you have to just decide कि whether I should reduce this. अगर reduce कर रहे हैं तो सिर्फ constant लेके करना है या फिर उसको divide करना है, या फिर you just need to you just wish to utilize the original values. Original value का utilization करने पे सोचो अगर ये आपका x है तो 360 का स्क्वायर 129600, a very big number. This is just one thing that I showed you. Imagine doing this with all these numbers here. You will have a very very big calculation to do. Okay, to cut that short, what I will show you here is how to deal with bigger numbers. आपका फॉर्मूला जो RXY का है वो अब हो जाएगा RUV का. Your RXY will be given by RUV. RUV given by covariance of U into V into D into D dash upon standard deviation U into standard deviation V. अब ये U और V क्या है? What is U and V? U is nothing but your original observation x reduced by any constant that you pick up from here only, ठीक है, यहीं से कहीं से लेंगे जैसे previous sum में किया था, divided by another constant d. Similarly your v will be y minus c dash. What is c dash? A value that you will pick up from these variables upon d dash. D dash is some other variable. Okay, I hope you remember we have done this thing while calculating standard deviation in the previous chapter. Time and again I'm reminding you of that. Okay, so it becomes easy for you. Now, again, the formula for COV of UV will remain the same. No changes. Okay, COV of UV is given by this. V by N. Okay, standard deviation of U is square root of summation of U square by N minus summation of U by N the whole square. Similarly, standard deviation of V, summation of V square by N minus summation of V by N the whole square. Okay? Now, what do we need to do? We need to find the values of U and V. Let me write the sum as given. I'll take income as X, okay, and expenditure as Y. So X is 360, 420. Let me just, 500. 550, 600, 640, 680, 720 and 750. Okay, my small y is 100, 104, 115, 160, 180, 290, 300, 320 and 330. Okay, I have written the sum as it is. Now it is the time that I calculate small u. Small u will be my original observation x minus some reduced value जो है c. यहाँ पे मैं I will take my c as 600. ठीक है, this will be my c and 180 will be my c dash. So u will be given by x minus 600 upon, I will take the value of d as 10. How? 360 minus 600 will give you minus 240 divided by 10, which is 24. Okay. Yep, I'm taking this as 10. Okay, similar calculations I'll do. 420 minus 600 is minus 180. Minus 180 by 10, yep, is minus 18. Okay, similarly you will get 500 minus 600 is 100 by 10 is minus 10. You have your minus 5, 0. Okay, we have 4, 8, 12 and 15. Okay, simple. V will be given by my y minus my original value reduced by 180 upon, take this as 0.1. Let's see what happens. Okay, 100 minus 180 gives 80 divided by 10 is 8. I'll take this as 10 rather. Okay, I get minus 8. Then 104 minus 180 divided by 10, which is 7.6. Similarly, 115 minus 180 divided by 10, which is minus of 6.5. Then you have 160 minus 180 minus 2, 0 to 90 minus 180 upon 10, that is 11, 12, 14 and 15. Yeah, you get these values. Okay, what did I do? I reduced my original values to 180 and divided by 10. So my d and d dash is 10. See, this is completely your wish as discussed in the last chapter what to take. Here I have taken it as 10 and 10. Okay, now you can see how my dangerous 3-digit variables have been reduced to some 2 1-digit variables. Okay, now I have to do the same thing. u और v को मल्टीप्लाई करना है, u स्क्वायर ढूंढना है, v स्क्वायर ढूंढना है. ठीक है, easy thing. You just have to multiply these numbers. I write the values. 18 into 7.6, both are negative, hence you get a positive answer. 136.8. Here you have 65. 6.5 into 10 is 65, right? 5 2s are 10. 0, 44, yeah, 12 8s 96, 12 into 14 is 168, and 15 into 15 is 255. Okay, I need to find u ka square, that is square of this. 24 square 576. Yeah, 18 square is 304, 10 square is 100, 5 square 25, 0, 4 4s are 16, 8 is 64, 12 12s are 144, this is 6. Okay, 15 square is 250, 225. Yeah, v ka square, iska square. 8 square 64. Now square of 7.6 is easier to do on a calculator. You may verbally not know it, but you have a calculator, so you can obviously use that. 57.76, 42.25. You have 2 ka square is 4, 0, 11 square 121, 12 square 144, 14 square is 196, and 15 square is 225. Okay, now I need a summation of all these 5 values. मतलब इन सब का टोटल चाहिए मुझे. ठीक है, u का टोटल होगा -80, 27.9. This will be 936, 1474, and this will sum up to 854.01. Okay, now you don't have to do much, you just have to put things into your formula. First I'll find COV of u and v. Mind here, please remember your value of d and d dash is 10 each. Okay, COV of uv is u into v by n, summation u by n, summation v by n with a negative sign in between. Yes, yeah, you have, yeah, u into v 3936. How many observations do we have? 1 2 3 4 5 6 7 8 and 9. So your value of n is 9. Okay, I have 936 by 9 minus summation of u is -18 by 9, and this is 27.9 by 9. You can easily do this on your calculator. ठीक है, वैल्यू आएगा आपका 110.2. Yeah. Now standard deviation of u is given by summation u square by n minus summation u by n the whole square. ठीक है, put the values. 1474 by 9 minus 18 minus 18 by 9. Minus 18, however, when it will be squared, will become positive. Okay, get the value to be 12.64. See, I'll show you how. Okay, 1474 divided by 9 will be 163 point this. 9 to the 18 minus 4 square root of answer will be 12.64. Your summation of u will be 12.64. But do you remember we we divided our original observations by 10? So you will have to now multiply them by 10. ठीक है, हमने आगे के चैप्टर में भी डिस्कस किया है. जब हम यहाँ पे जिस नंबर से डिवाइड करते हैं उसी नंबर से यहाँ पे हमको मल्टीप्लाई करना पड़ेगा. ठीक है, सो आई हैव द वैल्यूज टू बी 126.4. Similarly, summation, sigma of y, standard deviation of y, is given by, instead v is given by sigma, that is summation of v square by n minus sigma of v by n the whole square, which is equals to summation v square. Summation v square was 854.01 by 9 minus summation v 27.9 by 9 the whole square. Upon doing this calculation, you will get the answer to be 9.234. But since we had divided our entire observations by 10 here to get the value of v, so I will multiply 10 here again to get my standard deviation for v. My standard deviation for v will be 92.34. Okay, now just put things into the formula. R of xy is equals to r of uv, which is equals to COV of uv into d into d dash. Please do not forget here d into d dash upon sigma u into sigma v. Okay, I have 110.2 into 10 into 10. What are these? This is the value of my d and this is the value of my d dash. In this sum we have the value of d and d dash to be same. Might not always be true. Okay, so take care. 126.4 into 92.34. Just calculate this on your calculator. ठीक है, आपका फाइनल आंसर आएगा 0.94. Value of your rxy will be positive 94. See, this is a perfect, nearing a perfect correlation. I hope you understood all the things which I discussed in this session here. If not, please feel free to ask for any doubts if they are there. Okay, you can contact me on my cell number unless it is quite urgent, or drop in a mail, or post it on the WhatsApp group. I should address the doubts. That's it for today's session. Thank you.